Find all complex solutions for x. X to the fourth power minus 625 equals 0. Well, to solve this, I have something to the fourth power, which generally isn't something that we can work through. But 625 is a special value. And the reason for that, let me grab the calculator to show you. The reason 625 is a special value is because it's a perfect square. And it might not be a perfect square that you recognize right off, and that's okay. Hopefully you'll get a generation of this question that has smaller numbers to work with, but it is a perfect square. It's 25 squared. So I could particularly change this problem into x squared, quantity squared, which is the same thing as x to the fourth, minus 25 quantity squared equals 0. And what that does is it sets me up in the difference of squares. So the difference of squares, what happens there is I have two perfect squares that are subtracted, which can be factored into the first item minus the second, and the first item plus the second. So that's what I'm going to do next. So this will factor into the first item minus the second times the first item plus the second. Now, if you'll notice, 25 you should recognize as a perfect square as well. So 25 being a perfect square, and then x squared minus 25 tells me that I can do another round of difference of squares. So this first parentheses could factor into x minus 5 times x plus 5, but this next one doesn't factor. It just stays as x squared plus 25. Now, according to our principle of the products of factors that result with 0, so here I have three numbers that multiply together and their product is 0. So what that means is the first number could have been 0, the second number could have been 0, or the third number could have been 0. And that allows me to split this up into three separate equations that I can solve independently. The first one's linear. All I have to do is just add 5 to both sides. So x equals 5 is a solution. The second one is also linear. All I have to do is subtract 5 from both sides. And the third one, it's a quadratic, but it's a quadratic such that there is no linear term in it. So there's nothing just times x. And that's an easy version of the quadratic that you can solve. All you have to do is just take your constant to the other side, take the square root of both sides, and because you're taking the square root of a perfect square variable, that is, you have to make sure you consider the plus or minus square root. So this becomes x, and then I have the plus or minus square root of negative 25. Now, the square root of a negative number isn't technically defined, but if you go into the complex realm, it can be defined. In complex values, you enter that place by allowing I to be the square root of negative 1. So what we can say is that this would be the square plus or minus square root of negative 1 times 25. And when you have the square root of two things multiplied, you can split that up into individual products. And finally, the square root of negative 1 becomes I, and the square root of 25 is 5. So this just becomes 5 times I. So our four solutions here are 5, negative 5, positive 5i, and negative 5i.